Hey everyone, and welcome to The Explainer. Today we're tackling what's honestly one of the absolute most critical architecture decisions you're going to face when adopting Zero Trust network access and Secure Access Service Edge. We are talking about the showdown between Zscaler Tunnel 1.0 and Tunnel 2.0. Look, for CIOs, network architects, and security teams, just understanding what Zscaler does is only the beginning. Choosing the exact right tunnel architecture to connect your branch offices, data centers, and hybrid environments, well, that is where the rubber really meets the road.
So ask yourself this: are you building for today's network or the next decade? It's a serious question to chew on, because when it comes to connecting your infrastructure, the choice between these two tunnels literally dictates the future-proofing of your entire digital transformation. Here's our roadmap for today. We'll start with the modern connectivity challenge, then officially meet our two tunnels. After that, we'll put them head-to-head on architecture and security, dive into operations, automation, and AI, explore some industry-specific use cases, and finally, deliver the verdict. This is a structured, objective showdown focusing on real deployment scenarios. No marketing fluff today, just the architectural facts.
All right, Section 1, the modern connectivity challenge in securing the distributed enterprise.
To really get why this solution matters, we first have to look at why traditional networking is, well, kind of struggling to keep up. We're dealing with a massive, expanding perimeter today. We aren't just hooking up a couple of corporate headquarters anymore, right? We've got branch offices everywhere, data centers, crazy complex, multi-cloud environments, a huge remote workforce, IoT devices, and even OT environments like manufacturing plants. All these scattered locations need secure, continuous connectivity to the Zscaler cloud. Traditionally, Tunnel 1.0 handled this. But as organizations scaled up and became incredibly distributed, massive operational challenges popped up. And that complex scale is exactly what triggered the evolution to Tunnel 2.0.
Moving into Section 2, meet the tunnels, where we define our baselines. First up in the ring is Tunnel 1.0, what we can call the static highway. This relies on traditional networking protocols, using a GRE or IPsec-based forwarding architecture. Basically, traffic from your branches or data centers gets forwarded into Zscaler through static tunnels. It's literally like a physical highway connecting your office to Zscaler. The tunnel stays active and just continuously forwards traffic using static routing and manual failover configs. It's got limited traffic awareness, but let's be super clear here. This is a proven, incredibly mature model that has served enterprises perfectly for years.
And then we have Tunnel 2.0. You can think of this one as the software-defined smart grid. Instead of just blindly sending packets down a highway, Tunnel 2.0 totally changes the game. It brings in application awareness, highly intelligent tunnel management, and dynamic path optimization. This is a massive leap from traditional networking over to modern, software-defined, cloud-native networking principles. It is built from the ground up to be insanely scalable and totally automation-friendly.
Section 3, head-to-head on architecture and security. Let's get to the showdown.
Okay, when we compare the architectural core of these two, the differences are honestly pretty stark. With Tunnel 1.0, your routing is limited, telemetry is basic, and scalability is good. But jump over to Tunnel 2.0, routing gets upgraded with dynamic path selection, the telemetry becomes incredibly rich, and scalability goes straight to excellent. The operational overhead drops significantly. For large enterprises, this exact architectural flexibility is hands down the biggest driver for adopting Tunnel 2.0 over its predecessor.
Now what about security control? Look, both tunnels are going to give you solid, encrypted connectivity to the Zscaler cloud. That's a given. But while 1.0 gives you a proven, mature deployment model that fits traditional networks perfectly, Tunnel 2.0 introduces enhanced traffic intelligence. You're getting far better application identification, faster policy enforcement, and significantly better cloud workload visibility. The key takeaway? If you're actively building out a modern Zero Trust program, Tunnel 2.0 just aligns so much better with those strategies because of that superior visibility.
Let's talk resilience and disaster recovery. With Tunnel 1.0, you absolutely get high availability, but it relies on redundant tunnels that usually require manual failover planning. Translation: a stressed-out engineer getting paged at 3 a.m. to make routing changes. Compare that to Tunnel 2.0, you get intelligent path selection, way better traffic steering, and far faster recovery mechanisms. This kind of dynamic steering directly translates to what business leaders actually care about: reduced downtime, a better user experience, and uninterrupted business continuity.
Section 4. Operations, Automation, and AI, powering the modern SOC.
You know, implementation complexity is usually where organizations make their final call. If you're deploying Tunnel 1.0 across hundreds of locations, it can literally take several months. It means heavy network engineering, manual routing tweaks, extensive failover testing. It's a lot. But Tunnel 2.0, it offers a significantly faster deployment, often just weeks or days, completely driven by automation and better orchestration. That operational simplicity and the lower long-term support costs are exactly why CTOs and CISOs strongly favor rolling out Tunnel 2.0.
And the secret sauce behind that lightning-fast deployment is that Tunnel 2.0 is designed natively for modern automation and DevSecOps workflows. It loves infrastructure as code, API-driven deployments, automated policy updates, and deep cloud orchestration across AWS, Azure, and Google Cloud. It even plays nice with Kubernetes platforms. If you're trying to automate your infrastructure, Tunnel 1.0 is going to rely on traditional scripts and manual change management. Tunnel 2.0, on the other hand, is purpose-built for the job.
Plus, we can't talk about modern ops without bringing up AI, right? As security operations centers become increasingly AI-driven, the data you feed them matters immensely. Tunnel 1.0 gives you traditional monitoring, but Tunnel 2.0 hands you the incredibly rich telemetry needed to power behavioral analytics, anomaly detection, advanced traffic intelligence, and AI-assisted troubleshooting. For fast incident investigation, this rich data set from 2.0 is an absolute goldmine for your security teams.
Section 5, Industry Use Cases. Let's see where each architecture really shines. Take the telecom industry, for example. Providers are operating thousands of sites with just massive traffic volumes, so Tunnel 2.0 is highly recommended for its massive scalability. Banking and financial services? They demand super low latency, high resilience, and strict compliance. Again, Tunnel 2.0 wins out for digital banking. But look at the government sector. They heavily prioritize stability and predictability above all else. So both actually work perfectly well here. Tunnel 1.0 is totally acceptable for highly controlled environments, while Tunnel 2.0 is there for agencies undergoing modernization.
So let's distill this down to the exact sweet spots. The perfect home for Tunnel 1.0? Stable factory environments, organizations with a limited branch count, and highly controlled, predictable networks with really conservative operational models. Honestly, if you have a well-functioning Tunnel 1.0 setup in a stable environment and you aren't doing some massive cloud transformation, there is absolutely no urgent need to rip and replace it.
But contrast that with a Tunnel 2.0 sweet spot. We're talking about highly dynamic stuff. Smart factories driving Industry 4.0, IoT-heavy environments, multi-region digital banking, and multi-site aviation networks. These are mission-critical environments. If you've got global branch deployments that demand continuous, real-time operations, you absolutely require the intelligence, resilience, and operational scale that Tunnel 2.0 brings to the table.
Section 6, the final verdict, making your choice.
To sum it all up, your decision really boils down to this. Keep Tunnel 1.0 if you need a stable architecture, you've got minimal cloud transformation on the horizon, and your network operations are conservative. But choose Tunnel 2.0 for literally any new greenfield enterprise deployments, multi-cloud organizations, global rollouts, and environments running modern DevSecOps or AI-enabled SOCs. Tunnel 2.0 is simply the default choice for modern enterprise deployments. I actually want to highlight a quote straight from our source material that really hits the nail on the head. Tunnel 2.0 represents the future direction for enterprise-scale Zero Trust connectivity. While 1.0 remains incredibly stable and does exactly what it was built for perfectly, 2.0 is undeniably the direction that modern networking is heading. And that brings us to a final thought I want to leave you with. Are you building for today's network or the next decade of digital transformation? Look, the question isn't whether Tunnel 1.0 works, because it absolutely does. The real question is, what level of intelligence, automation, and resilience your infrastructure is going to need to support tomorrow. Thanks so much for joining me for this explainer. Hopefully you can use these insights as a roadmap as you architect your own Zero Trust deployments. Catch you next time.